What is going on, everybody? It's your boy Average Leader here with another video, and today we are tackling number 121, best time to buy and sell stock. This is a very old problem and also a very common one, and you can see that it's commonly asked by Amazon, Microsoft, Facebook, Google, Apple, Adobe, and a ton of these other companies. If you guys can go ahead and hit that subscribe and like button, that would mean the world to me. It helps my channel out a ton by giving it more exposure to people that don't know me. And if you want to see another problem done, just comment down below and I'll make sure to do it for you. And with that all out of the way, here we go. So you are given an array prices, where prices of index I is the price of a given stock on the ith day. Okay? You want to maximize your profit by choosing a single day to buy one stock and choosing a different day in the future to sell that stock. Okay, so we're only picking one day to buy, and it looks like we're only picking one other day in the future to sell. Return the maximum profit you can achieve from this transaction. If you cannot achieve any profit, return 0. Okay, so this is a pretty straightforward problem. Let's go ahead and look at this example in the iPad. Okay, so this is the example from Leetcode. And, the first time I saw this problem, I was thinking all we have to do is find the min and find the max and just subtract the max minus min. But when we further look into the problem, we see that through this strategy, the min would be right here at index 1 and the max would be right here at index 0. And this wouldn't really make a lot of sense because we want to buy a stock before selling it for a higher price in the future. So we quickly shoot down this idea. But then I was thinking, okay, instead of doing this, let's find the min, and then we'll find the max at any value after our minimum value index. And I thought this was a good idea because if we look at this example, our min is right here at index number 1, and then we see that if we search for any value after index 1, we see that the max would happen at 6. So this would give us a max profit of 5, and that's the actual answer to this problem. But then I started thinking about other arrays that maybe might disprove this strategy, and a quick one that came to mind was, okay, what if I had 7, 2, 5, 3, 6, and 1? Just switching out some of the numbers here. And in this situation, we see that the minimum would happen at the last index here, and because of this, we can't search for any value after our last index since we're at the end of the array. But if we looked a little further into this, we see that there is another min here at index number 1 and another max at index number 4, and this would give us a max profit of 4. But using this strategy up here, this wouldn't really work for us. So this one also would not work for us. But then I started thinking, what really matters here? If we looked at both the second example that I have and the first example, I think it's pretty clear that we only care about finding the minimum value from the left-hand side and finding any value that's larger at any index after it. And the minimum doesn't necessarily have to be the global minimum. It just has to be a local one. With this information, maybe we can think of another strategy to solve this problem. What if, and let me go ahead and erase some of this extra stuff. What if we kept track of our local minimum that we've seen so far and kept comparing any value after that with our local minimum? If that value is smaller than our local minimum, we'll reassign our local minimum to be that value. If we find a value that's larger than our local minimum, then let's make that the max profit that we've seen thus far, and we'll keep comparing any value that's greater than our minimum value to see if that difference is larger than our max profit that we've seen thus far, and we'll just keep calculating until we get to the end of our array. So using these 3 steps, we can find the max profit. So let's run these 3 steps on this example. And what I will do is keep these 3 steps on the side of the screen. So step 1, let's keep track of a local minimum. So to me, it makes the most sense to set our very first value of our prices in array to be the local minimum. That way we have something to compare to as we keep iterating through our array. And let's also keep track of our max profit that we've seen so far. Now, In the beginning, let's just initialize our max profit to 0. Let's just assume we have 0 profit. After we have a local minimum, let's iterate through everything after the 0th index, and let's check to see if the value is less than our local minimum or greater than our local minimum. So moving on to index number 1, we see that the value is 1. Is 1 less than our local minimum or greater? It's less than, and if that's the case, let's reassign our local minimum to the value of 1. And since we've reset our local minimum, it doesn't make sense to calculate our max profit, because all we would do is compare our value with our local minimum and see if that's greater than our max profit. But in this case, we just have 1 minus 1, so that would give us 0. That's not greater than our max profit. So anytime we reset our local minimum, let's just continue to the next value. So now let's go to the second index. Now we have a value of 5. This value isn't less than our local minimum, but it's greater than our local minimum. And every time we encounter a value that's greater than our local minimum, let's do a quick check to see if the difference between that value and the local minimum is greater than our maximum profit. In this case, 5 minus 1 is 4, and that is greater than our current maximum profit of 0. So let's reassign our max profit to 4. Okay, cool. Now let's go to index number 3. Now in index number 3, we have the value 3. Is 3 less than our local minimum? No, it's greater than our local minimum. Now let's check to see if the difference between the value and our local minimum is greater than our max profit. In this case, the difference between 3 and 1 is 2, and 2 isn't greater than our max profit, so let's just go on to the next value. Now we have 6. Once again, this value is not less than our local minimum, but it's greater than our local minimum. So now let's check to see if the difference between this value and the local minimum is greater than our max profit. In this case, it is. The difference between 6 and 1 is 5, and 5 is greater than our current max profit, so let's reassign our max profit to be 5. Cool. Now let's move on to the last value at index 5. At index 5, do we have a value that's less than or greater than our local minimum? It's greater than. So if it's greater than our local minimum, let's check to see if the difference between that value and the local minimum is greater than our max profit. In this case, the difference is only 3. So it's not greater than our max profit, so let's not reassign our max profit. And after we're done iterating through all our values here, we see that our max profit is 5, and this is the actual answer. We can see that this is the one that Leetcode also has. Alright, so that's how you do this problem, everyone. Hopefully this made sense. Now let's dive into the code. Alright, who is ready for some code? I know I am. Alright, so let's start with, what are we trying to return? We're trying to return the max profit. So let's just make a variable called max profit, and we'll set it equal to 0. And this will be the variable that we'll return at the end of our code. And next, we are going to iterate through our entire prices array. But before we do that, we need to calculate the local minimum value that we've seen thus far. And like we did in the example, we're going to set the local minimum to the 0th index of our prices array. So let's assign a variable named minnum equal to the prices of the 0th index. So now we have a max profit, and we have a variable accounting for the minimum value that we've seen so far. So now all we have to do is iterate through our prices array. And since we have the minimum number at the index 0, let's just iterate from index 1 all the way to the end of the array. So for int I equals 1, I is less than prices.length I plus plus. And every time we iterate through, we're going to make one simple check. If the prices at index I is less than our min num, what do you guys think we need to do? Just like we did in the example, we are going to reassign our minimum number that we've seen so far, our local minimum, to the value that we're at in our prices array. So it's going to be prices of I. And like we did before, since we have recalculated our minimum number, there's no need to recalculate our max profit. So let's just continue to the next value. And assuming that this doesn't trigger, we need to check if the difference between the value that we're at with our minimum value is greater than our max profit. So let's put that in another conditional. So if prices of index I minus the min num, the minimum value, is greater than our max profit, let's reset our max profit to be this difference. Minus min num. And I believe that is it. Very simple. Let's go ahead and run this and see if this will compile and run. Okay, amazing. We've got an accepted answer. The only thing that I would be worried about is we start off with accessing the 0th index. But what happens if the prices array is empty or null or something? So to combat that, we'll do one quick thing in the very, very beginning. We'll just check to see if our array isn't empty. So if it is empty, let's just return a max profit of 0. So if the prices.length equals 0, or prices equals null, then let's just return 0. And I believe this will check like any edge cases that we get thrown at us. So let's just run one more time. That should compile and we'll submit. And that is everything, everyone. Look at that. We are 1 millisecond faster than 98% of the Java Online submissions. Let's talk about the time and space complexity for this problem. So the bulk of our complexity actually happens in this for loop. And since we are basically iterating through our entire array, our time complexity is O of n. And our space complexity, well, we're not really storing any additional storage. So our space complexity for this is O of 1. So yeah, guys, I mean, that's how you do this problem. If you found any value from this video, go ahead and hit that like button and subscribe to the channel, and comment down any other problem you want to see done. I'll make sure to do it for you guys. I'll even tag you guys in the video. And with that all out of the way, I hope you guys have a great rest of the day, and I will see you guys next time.